So we're going to start this GCSE Maths revision course. For the first day, day one, the topics are like this. We'll start with the basic topics like number system, factors and multiples, fractions, decimals, and percentages. Okay, so we'll be covering these topics from numbers, and then we'll also get into algebra, which is a very important topic in GCSE. So we'll start with surds, powers, and nth roots, and then also go to algebra basics, and then arithmetic sequences, the finding the nth term of arithmetic sequences, and quadratic sequences. Okay, is that fine, everyone? Is it? Hello?
Yeah.
Yeah,
that should be fine.
Yes, can everyone please mute yourself? I'll ask you to unmute. When you're asked to unmute, you can unmute. Okay. Now let's start with first types of numbers. Maybe you're all aware of it. Just let me list them. The types of numbers. You have whole numbers. Can someone unmute yourself and tell me what are whole numbers? One of you. Yes. What are whole numbers?
A decimal.
Go ahead.
Not decimals.
Okay. Okay. And whole numbers are numbers that is starting from 0, right? You have 0. You have 0, 1.
Hi. Sorry.
Yeah.
Sorry to interrupt.
And so yeah.
Some of my friends are struggling to log in. Could you send the Zoom ID directly to me and I'll pass it on to them? They've registered.
Yes, the team will get back to them. Okay. Yeah, and then we have also whole numbers, and then we have natural numbers. What are natural numbers?
I don't know.
The natural numbers are those numbers that are starting from 1.
Positive and infinity?
Yes, 1.
Negative
Yes,
and equal to infinity.
You don't add the negative numbers, but it is from 1. All the positive numbers, excluding 0. We have all the positive numbers. So those are natural numbers. And then we have the third type of numbers. We're going to look at these integers. Okay, integers are those numbers that are both negatives and positives. So minus infinity, comma, say -2, -1, 0, and 1, 2, 3, and so on up to positive infinity. So you have all these numbers are called integers. So you have whole numbers starting from 0 to infinity, positive numbers, and the natural numbers starting from 1 to infinity. Then integers, you have both negatives and positives, including 0. And then the third one is fourth one is rational numbers. So what are rational numbers? All the numbers which are in the form of P over Q, okay, which are in the form of P over Q are rational numbers. For example, you have 2 over 3, 4 over 5, and so on. Okay, so these are all rational numbers. And then you also have irrational numbers. Irrational numbers. Irrational numbers are those numbers basically when you see them, you have like this √2, √3, √4, √5, and so on. Okay, these are all irrational numbers. So you have whole numbers, you have natural numbers, integers, rational numbers, and then irrational numbers. And then you also know complex numbers, right? Complex numbers or imaginary numbers, which are basically imaginary complex numbers. You can write them as I, so which you are not, which are when you have the square root of a certain number as a negative number, you get the square root of a negative number is an imaginary number. Okay, so basically you have I square is equal to -1. So basically you will need to understand this: whole numbers, natural numbers, integers, rational numbers, and irrational numbers. Is this clear to everyone?
Yeah.
Yeah.
Yes. Wonderful.
Fine with me.
Yes. Yeah. Next, we're coming to the next slide, that is you have multiples, factors, and prime factors. I think I don't need to tell you, since you're a GCSE student, you don't need to know what is multiples and factors. You already know them. But let's look at prime factorization. Just let me give you an example of a prime factorization. For example, you have 420. Okay, how do you write this number? How do you write the prime factors of this number? So if you can do this, okay, 2 times 2, 210, right? 2 times 210 is 420, right?
Yes. Yes.
And then you have 2 times 105. You see, you do a tree diagram kind of thing, and then you have 105 goes in 3, so 3 times 35, and then you have 5 times 7. So basically, you can write this as 420 can be written as, if you see that 420 can be written as,
should have 3 and then
3 times 3 times 5 times 7. Can you see that, all of you?
Yep.
Yeah.
Yeah, wonderful, wonderful. Joel, I think you need to mute yourself, Joel. Yeah. So this is how we write prime factors of any number. So basically, you do this tree diagram, and you start from the lowest number, and you do this. Okay. So this is how you do a tree diagram. Next, LCM and HCF. Okay. You know, LCM is again, this is a very basic stuff. LCM is the least common multiple. Yes, least or lowest common multiple. Good. And HCF is highest common factor. Okay. Highest common factor. Now you look here. Now see, let's do for example. Let's do for 2 numbers, 10 and 25. So let's find the LCM of 10 and 25. So for 10, what are the multiples of 10? It is. Can you list them? Can someone want to list them?
1, 2, 5.
1,
1, 2, 5, and 10.
I mean multiples. I'm asking, not the factors.
10,
Oh.
20, 30, 40, 50,
40.
60, 70,
Yes.
80.
Yes. You go on like this: 10, 20, 40, 50, 60, and so on. Okay. And for 25, you have the multiples are 25, 50, and 75, and 100, and so on, right? And so on. Now, what you do is you'll find the lowest common multiple. You see, 50 is the
50.
lowest common multiple, right? So therefore, LCM is 50, right?
Yeah.
Now, for the same number, if you have to find HCF, okay, if you have to find the HCF, so HCF can be done by finding the factors. Now, what are the factors of 10 and 25? 10 factors, like one of you said before, it is 1,
1, 2, and 5.
5, 10. Good. And for 25, the factors are 1,
1, 5, 5.
50, 25, and 25. That's it, right? So the highest common factor you see this 5 is the highest common factor, right? So therefore, HCF is 5. Make sense, guys?
Yeah.
Wonderful.
Yep.
Yeah, Ria, does that make sense, Ria? Daniel? Yes, good. Let's do some few questions, guys. I mean, before we go to algebra, let's do some questions. I'll put these questions here. I want you to do this, and I mean, maybe after a given time, like I'll write the time here. After the time, I mean, I'll ask you the answer. Maybe one of you can give the answer. Maybe a few of you can give the answer. Here's the first question. You need to finish this question in 2 minutes. Can we do that? Here you go. The first A1 should not take you more than 10 seconds. The B you should be writing as a prime factors, like the one we did before. Circle the numbers which are multiples of 7. Okay, circle the numbers which are the multiples of 7. And in,
Stuff.
good, wonderful,
Done.
wonderful, good.
Done.
I'm done.
Done.
Wonderful, excellent. Yes. So yeah, what is the among the list of numbers? What is the multiple of 7?
28.
28. That's very easy, right? 28. 7 times 4 is 28. Wonderful. Now 180 can be written as a to the power of p times b to the power of q times c to the power of r. So how do you write this? 180.
2 squared times 3
factor.
squared
2 squared
times
3 squared times 5. 5.
Excellent.
And
Excellent.
And
Excellent.
divided by. And
Excellent. So you can do it this way. 2 times 90 is 180, and 2 times 45, and 3 times 15, right? Am I right? And again 3 times 5. So basically you can write 180 as 2 squared times 3
3
squared
squared.
times 5 to the power of 1. So basically a to the power of p, b to the power of q, c to the power of r. So p is 2, you see, p is 2, q is 2, and r is 1. So you're asked to find p plus q plus r. P plus q plus r is 2 plus 2 plus 1,
5.
which is 5. So your answer is 5. So, I mean, I hope all of you got the answer as 5. Wonderful. Can we go to the next question, guys?
Yeah.
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 Yeah, wonderful. Any questions? Anyone has any doubts on this question? Good. Let's go to the next question. Here you go. Find the highest common factor of 64 and 100, and find the lowest common multiple of 88 and 120. Maybe again, you can take up to 90 seconds, so 1.5 minutes for this question. Go ahead. Can you all switch on your videos, guys? Is it possible? Good. Five. Tina, good. Find the highest common factor of 64 and 100. 64 and 100. And the lowest common multiple of 88 and 120. So you can, first of all, for the lowest common multiple, let's come to the lowest common multiple, 88 and 120. Is anyone done with this?
I'm done.
Yep.
Yes.
Yep.
I've finished, sir.
Yes. What is your answer?
For the LCM, I got 1320.
1, 3,
20.
2, 0. And for the highest common factor,
I got 4.
4. Is it correct, guys?
Yes, I've got 4 too. I got the same.
Yes.
He's right.
Okay.
Yeah, same.
So
Same.
wonderful. Good. So highest common factor is 4, and the LCM is 1320. Let's check. Let me show you another method for LCM. Okay, you can also do this. Okay, 2 44s is 88, 2 60s is 120, and then 2 22s is 44, 2 30s is 60, 2 11s 22, and 2 15s 30. Right?
Yeah.
Am I correct, guys?
Yeah.
So basically, you get 2 cubed times 11 times 15. Okay. So 2 cube is 8. 8 times 11 times 15. So maybe let's multiply this. 8 times 11 times 15 is 1320. So you see, maybe, I mean, if you know this method, it will be really easier to you. You can do that. It will become really easy for you. Okay. And regarding highest common factor, you need to list out the factors, and you said 4. That's the correct answer. Okay, let's go to the next question, guys. Write 424 as a product of 5 prime factors. 30 seconds.
It's saying Barbara. Yeah, sure it is a strong connection. Yeah. Maybe open the door. So goodbye. Oh, I already missed the questions.
Oh,
Oh, sorry.
Przepraszam bardzo, proszę.
I'm sorry.
Przepraszam, że podniosłaś głos, że była wśród i coś takiego. Przepraszam.
So I finished. I got 2, 3 comments.
I'm done.
Dan, good. Rahul, good.
Done.
Anna, good.
Done.
Anna, good.
Done.
Princess, good.
Done too.
Wonderful, wonderful.
Done.
Yes, wonderful. So 424, you are writing as a product of prime factors. So you'll do that. Okay, let's do a tree
Why
diagram.
424?
Yes, it is 2 times 212, right? And then 2 times 106. And it is 2 times 53. And
2
53 is
cubed times 53.
yes, it is 2 cubed times 53, which is 8 times 53, right? Yeah, good. Yeah, it is 2 cubed times 53. Wonderful. Excellent. Let's go to the next question.
Będziesz miała później to wszystko.
Okay. Now we're coming to the fractions. Here is a list of fractions. One of these fractions is not equivalent to 1 over 4. Okay, one of these fractions is not equivalent to 1 over 4. Which fraction is that?
I'm sorry.
Nie, ale
7 over 12.
7 over 21.
Which is, what is that?
7 over 12.
1/3.
7 over 21. It is 1 over 3, right?
Yep.
Yeah. Good. See, you see, 3 over 12 is 1 over 4. 4 over 16 is 1 over 4. 7 over 21 is 1 over 3, whereas there is 1 over 4, and this is also 1 over 4. So basically 7 over 21. Now, before we go further, for those who don't know, how do we add fractions and subtract fractions? Just a recap. For example, we have 1 over 2 plus 3 over 4. Okay.
Need to make
Make the denominators the same.
common denominator.
You have a common denominator, or you find the LCM of the denominators, which is 4 here in this case. So 2.
So 2 plus 3.
2 plus 3, which is 5 over 4. Okay. So the same goes with subtraction as well. You do the same thing. For example, you have 1 over 2 minus 3 over 4. So what you do is, again, you take common denominator. You can do also this one. You multiply this with 2 and this also with 2. You have 2 over 4 minus 3 over 4. So you have 2 minus 3 over 4, which is negative 1 over 4. Right? Am I correct? Am I correct, guys?
Yeah.
Yes. Now, when it comes to multiplication of two fractions, see, 1 over 2 times 3 over 4 is you multiply the numerators and you multiply the denominator. So it is 3 over 8, right?
Yeah. Yep.
And when it comes to division, for example, you have 1 over 2 divided by 3 over 4. So what you do is you can convert division to multiplication by just flipping the second fraction. Okay, just remember this word, flip the second fraction. So you have 1 over 2 times 4 over 3. Okay, so you flipped it. You converted the division to multiplication and you're flipping the second fraction. Anna, you need to mute yourself. So it is 4 over 6, which is 2 over 3. Okay. So this is to do with addition, subtraction, multiplication, and division of fractions. Now you have this one, right? 265 over 7 divided by 445 over 2 as decimal. Can you do that? You have 1 minute time for that.
Yeah. Done.
Are we allowed a calculator?
No. Maybe you can use calculator. Yes. When you're asked to write as a decimal, yes. Go ahead.
Surds is 0.24.
Good. Is he correct? I mean, I think it is Rahul who gave this answer. Is he correct?
Yes.
Yes, he is very correct.
He's correct.
Because 227 times 2 is 534.
Yeah.
If 2225.
Yeah.
And when you do 534 divided by 2225, you get 0.24.
Wonderful. Good. So it is 0.24. Excellent. Excellent. Let's go to the next question, guys. Here we go. Write the following in order of size, starting with the smallest number. Write the following in the order of size, starting with the smallest number.
Sorry, sir, the last equation you just explained, I couldn't understand. So is it possible, can you explain? Yeah, yes, this one. Sorry,
This
I didn't
one.
get it. Yes,
Yeah.
please.
Okay.
Thank you.
Okay, let me, good. It is 265. Let's do this again for Hina. It is 267 over 5 divided by, so it is 445 over 2. Right, Hina? So now you can convert this division to multiplication, Hina, by flipping the fraction, okay? So let's flip this fraction. We have 267 over 5 times 2 over 445, right? The second fraction is flipped because you are converting division to multiplication. The second fraction is flipped. Now let's multiply 267 times 2. This is 534. And 5 times 445 is, how much is that, Hina?
2.
It is 2225, right? So now you can divide this using your calculator. It is 534, maybe divided by 2225 is 0.24. You see that? Makes sense, Hina?
Yeah. Yeah, thank you.
Wonderful. Good. Let's go to the next question, guys. Now, yeah, here you go. You're asked to write the following in, you're just comparing the decimals. So, yes, go ahead. What is the smallest of all?
0.30.
0.31,
Yes.
0.303, 0.31, 0.3274, 0.33.
Wonderful. Good.
I agree.
Is it Meher Mishra that gave answer? Yes. Good. So the smallest is 0.303, and then it is 0.31, and then it is 0.3274, and then it is 0.338. Am I correct, guys?
Yeah.
Is this correct?
Correct. Yep.
Yes.
Yeah.
Wonderful. Wonderful. Good. Good. Next question. Here we go. 35% of the students at school cycle to school. Okay.
Hello?
Yes. Who is that? Yes.
You
Go
know
ahead.
the
Purva.
the last question, how
Okay.
you arranged the, yeah? I don't
Yeah.
understand how you did that.
Okay. See, you're asked to arrange from the starting with the smallest. Okay. So 30 is the smallest, and then 31, and then 32, and then 33. Right? You see that?
Yeah.
0.303 is the smallest, and then you have 0.31, and then you have 0.3274, and then the the largest is 0.338. It is just writing the numbers, writing these decimals in ascending order. Right, Dhruva?
Yeah, I understand.
Makes sense?
Sir,
Yeah.
sir, it's because
Go ahead.
the 0.31 becomes 0.310. So she will understand better.
Yes.
You have to convert everything. Yeah, there we go. Thank you, sir.
Great. Thank you. Yeah, it is 0.332, 74, and then 0.338. Good. Wonderful. Let's go to the next question. Okay, 35% of the students
65%.
at school cycle to school. Work out the percentage of students who do not cycle to school.
65%?
Yes, obviously it is 65%.
65.
Wonderful. Next one. Write 0.18 This is a non-terminating decimal. You understand that as fraction. How do you write that as a fraction? Wait, don't give answers. Don't give answers. Wait, let everyone do it. Don't just give answers. I'll ask you.
Sir,
Yes, Mishra.
is that a
Go ahead.
recurring decimal or?
What is that? Recurring decimal. Yes, yes, yes. It is x is equal to, you write it as 0.181818. Keep repeating like this. Okay. So how do you write this as a fraction?
I
Go
thought
ahead.
that, yeah, I thought that if there's a decimal, like if there was like a dot on top of it, then it would be like reoccurring. But yeah.
Yeah, it is recurring. See, 181818 and so on. Yes.
So I've got my answer 2/11 as simplified fraction.
Okay.
Yes.
Let's check. Okay. See, because you have 2 digits under the bar, so it is 100x. You multiply by 100, so you have 100x is equal to 18.181818 and so on. And then from that you subtract 10x, you get 1.818 18 and so on. Okay, so you subtract these two, you get 99x. 99x, sorry, minus x, right? Just a minute. Sorry. Yeah, minus x is equal to, it is 1.8181 and so on. So you have 99x is equal to, basically, it is
X
17.
is 0.8181, not 1.8181, right?
Just a minute. Okay. X is, yeah, it's 0. Let's take this equation 1. Okay. It is 0.18181818 and so on. Okay. So you're subtracting it. So 99x is equal to, you have 18, right? So x is equal to 18/99. Okay. You see that?
Wouldn't it be 10x minus x though?
Yes, 10x minus
like,
x is 99x, right?
But then, wait, if you times x by 100, it should be 181.8181 recurring.
No, see, it is 0.181818 and so on, right? You're multiplying this with 100. So when you multiply with 100, your decimal moves 2 digits to the right. So it is 18.181818 and so on, right?
Yeah.
So 100x, you're multiplying by 100. This equation, you're multiplying by 100. So you have 100 times x is 100x is equal to 18.181818 and so on. From that, you're subtracting x. X is, already know it is 0.181818. So when you subtract 100x minus x, it is 99x is equal to 18, right? So x is equal to 18/99.
Yeah, I get it.
Sorry, teacher.
Next.
Can it be simplified? Because they both go into 9.
Go ahead. You can do that, I think.
They're like 2/11.
2 9s, 18. I mean, okay. 9 2s, 18, 2/11. Okay. Go ahead. Maybe if you check your answer, 2 divided by 11 is, yes, you can. Yes, 2/11. Yes. You can write this, this as, anything is okay.
Yeah.
Makes sense? Good.
Yeah.
Wonderful, wonderful, princess. Nice. Let's go to the next question. Here you go. Round the decimal. This is very easy. Okay. 0.011122, two significant figures.
0.011.
0. Yes, it is 0.011. Good. And 3 decimal points.
0.011.
0.011.
How about 3 decimal points if it is 0.0117?
0.012.
Yes, if it is, you already know that, right? If it's 5 or more than that, it is rounded off to the next digit. So 0.012, right? Yeah. Wonderful.
Yeah.
Excellent. Good. Next question. The picture, okay, let me zoom it in a bit. Okay. Yeah, the picture shows a box next to a telephone mast. The box has a length of 1.5 meters. The box and the telephone mast are drawn to the same scale. Work out an estimate for the height in meters of the telephone mast.
Hey, check. Where are you, in the garden room? Okay, come on then.
See, I mean, it is 2 centimeters. If you see this, it is 2 centimeters is 1.5 meters. Okay. Basically, if you see this, it is 2 centimeters is 1.5 meters. So the scale is basically.
I'll just say, all I have to do is listen. That's all. Just see if any of it makes any kind of.
Fernandez, you need to mute yourself, Fernandez.
Sorry.
Yeah. 2 centimeters is to 150 centimeters. So it is 1 centimeters is the scale is 75 centimeters. So if you measure it, basically maybe you need to measure it. It is 12.4 centimeters. Okay.
Sorry, how do you know? Sorry, so how do you know that it's 2 centimeters?
You need to measure it with the scale.
With a what?
With the scale.
What? What's
The ruler. The ruler.
A ruler.
The ruler, yeah.
Oh, as in like if we the ruler in the examination.
Yes.
Okay. Then.
So 2 centimeters is 1.5 meters. You see that? So I mean, I'm giving you for now. I'm giving you it is 2 centimeters. So 2 centimeters is 1.5 meters. So the scale is 2 centimeters to 150 centimeters. 1.5 meters is 150 centimeters. So 1 centimeter is 75 centimeter. So this is 12.4 centimeters. The telephone mast is 12.4 centimeters. So the height would be 12.4 times 75. So which is, how much is that? Can you calculate that? 12.4 times
930.
930.
Yes, it is 930, which is, I mean, in meters, it is, the answer would be 9.3 meters, right? You understand?
Yeah.
Yeah.
Makes sense? Good.
Yeah.
Wonderful.
Yeah.
Next question. Now we're coming to algebra. This is to do with the surds. So let's do this. Let's solve this. Let's simplify this basically. You have 2 minutes time to do this. Can you do that, all of you?
Sir, are we allowed calculators?
What is that? Are you allowed?
Calculators.
No. You need to give your answer as a surd, I think. Because it says you must show your working.
To rationalize this.
So I got an answer of 223.
Mm-hmm.
I've got 223.
Good. Nathan, Ramya,
I almost have the answer.
good. Adnav, Vanilla. What about you, Vanilla?
Oh, I'm doing it, sir.
Okay, wonderful. Prashant,
Yep. Got the same answer as everyone else.
good. So let's do it together, guys. For those who are not able to do it, let's do it together. Look here. Let's multiply the numerator. Okay, let's first simplify the numerator. Let's multiply it. You have 7 minus root 3 times 7 plus root 3. So if you know the formulas, you have this formula. Okay, you need to memorize these formulas. you have a minus b times a plus b. If you see this, you have this can be written as a square minus b square, right? So 7 minus root 3 times 7 plus root 3 can be written as 7 square minus root 3 whole square. Can I do that, guys? Divided by root 23. You can do it this way. You can use the formula, or you can also multiply. See, 7 times 7 is 49 minus plus 7 root 3 minus 7 root 3 plus minus root 3 times root 3 is 3. Okay, so you have if you see here, you have minus plus 7 root 3 and minus 7 root 3 cancel. You have 49 minus root 3 in the numerator divided by root 23. Okay, so you can do it. You can use this formula. If you use this formula, basically you'll be able to do it in one step. Okay, a minus b times a plus b is a square minus b square. So 7 square is 49 minus root 3 whole square is okay. You need to you can cancel the square and root. 49 minus 3 over root 3, root 23. So which is basically 49 minus 3 is 46 over root 23. Now you need to rationalize the denominator. Okay, so for rationalizing the denominator, you multiply the numerator and denominator with the rationalizing factor of the denominator. So root 23 is the rationalizing factor here. So you have 46 root 23 divided by root 23 times root 23 is just 23. Okay, is it correct? I mean, guys, are you following me?
Yeah.
Okay. So 23 times 2 is 46. So you have 2 root 23. See that? Makes sense?
Yep.
Wonderful.
Yes. Can we have another similar question?
You want to do one more question like this?
Yes, please.
Yes. Okay. Let me frame this. Okay. You have 25 minus root 5 times 25 plus root 5. Or else, okay. Let me give something else. Root 3 minus root 2 times root 3 plus root 2 over 5 plus 2 root 3. Go ahead. You need to rationalize the denominator. First multiply. Bobson, you have a nice background, I think. Bobson, are you working on this? Ria? Mercy? Arnav? Arnav, are you working on this or no?
Good. Sir, I got the answer of 5 minus 2 root 3 over 13.
Okay, let's check. I mean, I framed this question, so I mean, we'll do it together and then we'll know the answer. Okay, so let's do it together, guys. Those who have completed it is good. For others, let's do it together. See, again, you have, see, this is of the form a minus b times a plus b. Okay, so you can directly simplify the numerator as root 3 whole square minus root 2 whole square. That's numerator. Okay, divided by 5 plus 2 root 3. Is this step clear?
Yeah.
Okay. So root 3 whole square. Root 3 whole square is 3 and root 2 whole square is 2. So you have 3 minus 2 over 5 plus 2 root 3. Right?
Yep.
Okay. So you have that is 1 over 5 plus 2 root 3. Now you need to rationalize the denominator. You cannot leave your answer at this point. You have to rationalize your denominator. So it is, you'll write it as the rationalizing factor is 5 minus 2 root 3. 5 plus 2 root 3, the rationalizing factor is 5 minus 2 root 3. So you multiply the numerator and denominator with the rationalizing factor of the denominator. That is 5 minus 2 root 3. Is this step clear, guys?
Why is it 5 minus root 3? The minus?
Because usually, I mean, see the answer. I mean, the answer is if you have the plus, you'll put minus. That will be your rationalizing factor. But let me show you. 5 plus 2 root 3 times 5 minus 2 root 3. If you multiply this, you will not have a surd. You see, if you multiply these two, you will not have a surd. Can you see that? 5 square minus 2 root 3 whole square. So that is 5 square is 25 minus 4 times 3 is 12. So 25 minus 12 is 13. So you see, if you multiply this 5 plus 2 root 3 with 5 minus 2 root 3, it is rationalized. So therefore, the rationalizing factor of 5 plus 2 root 3 is 5 minus 2 root 3. Does that make sense, Anjani?
But if you do 5 plus 2 root 3 as well, wouldn't you still get a whole number? So
No, you won't get it. No, you won't get a whole number. 5 plus 2 root 3 times 5 plus 2 root 3.
Oh.
Let me show you. 5 plus 2 root 3 times 5 plus 2 root 3. If you see that, you see here. It is 5 times 5 is 25. And 5 times 2 root 3 is 10 root 3. And 5 times 2 root 3 is again 10 root 3. And 2 root 3 times 2 root 3 is 4 is 12. Okay. So plus 12. We have 25 plus 12 is 37 plus 20 root 3. You see that?
Ah, okay. My bad. I did it wrong. Sorry.
Yeah. So you won't, I mean, you will still have a surd basically. So, but then when you multiply with the opposite sign, you will, I mean, the surd will be rationalized. Therefore, the rationalizing factor of 5 plus 2 root 3 would be 5 minus 2 root 3. Okay. Good. So now, see, let's multiply the numerator. 1 times 5 minus 2 root 3 is 5 minus 2 root 3. And let's multiply the denominators. 5 plus 2 root 3 times 5 minus 2 root 3. A plus b times a minus b, a square, that is 5 square, minus 2 root 3 whole square. So basically you have 5 minus 2 root 3 divided by 5 square is 25 minus 2 root 3 whole square is 2 square is 4 times 3, 12. Okay. So basically you get 5 minus 2 root 3 over 25 minus 12 is 13. Am I correct, guys?
Yeah.
For those, yes, Nishan, thank you. Princess, am I correct, Princess?
Yeah.
Rahul?
Yep, you're correct, sir.
Thank you, thank you. Wonderful. Ria, did you check this? Ria, you here? Okay, good. Let's go to the next question. Let's go to the next question. Here you go. Link the algebra to the most accurate description, okay? C is equal to, for example, you're given C is equal to 2 pi r is a formula. Next, 2 times x plus 4y is equal to 2x plus 8y. What is that?
Equation.
Equation.
It's an equation as well. I mean, for those who told equation, yes, it is an equation as well, but more aptly it would be a distributive property. Okay.
The next one's an equation.
4x plus 3 is equal to 19 is an equation. Good.
Equation.
5x plus 7 is an expression.
And the last one, inequality.
Is an inequality. Okay. Now, what is the difference between an equation and an expression?
Equation is equal to something. It has the equal symbol.
Yes, equation basically has an equal to sign. It is equal to something. And an expression doesn't have an equal to sign. That's an equation. And an inequality is you have an inequality sign, whether greater than or less than, you have an inequality sign. Okay.
Sir, what's distributive property?
Yeah.
Wonderful.
It also has a equal sign to it.
Yeah. Distributive property is basically you have A times B plus C is A times B plus A times C. Okay. AB plus AC. That's distributive property. The A is basically the A is distributed among both the terms in the bracket. Okay. Make sense?
Yep. Yes.
Wonderful. Good. Good.
Kind of.
Good that you're asking questions, guys. Next. This is to do with indices. You have, I mean, you can try this question. You can take about 2 minutes to finish this question. Go ahead, all of you. All three. A, B, C. And I'll ask one of you. Okay? Don't give answers. I'll ask one of you.
Finished.
Good, good.
Finish, sir.
Good. Ashna Sinha. Nikhil.
Yes.
Yes. Are you able to do this, Ashna?
Yeah.
Wonderful. Good. Nikhil. Yashwant. Yashwant and Tavnish. Okay. Okay, for the first one, 2 to the power of 5 times 2 to the power of 6. It is, see, you have a loss of indices. If you, I mean, let's revise if it is, okay. So you have a different loss of indices. Okay, now let me list them. Okay, number 1 is, look here, a to the power of m times a to the power of n is a to the power of m plus n. Okay, so when you have the bases equal and there is a multiplication sign, you can add the exponents. So a to the power of m plus n. The second one is, second law is a to the power of m divided by a to the power of n is a to the power of m minus n. Okay, that's the second law. When there is a, for example, let me give an example. Okay, for example, you have 2 to the power of 7. Okay, 2 to the power of 7 over 2 to the power of 3. So you can write it as 2 to the power of 7 minus 3, which is 2 to the power of 4. Right? You see that? Guys, do you see that?
Yeah.
And then 2 to the power of 7 times 2 to the power of 3 would be 2 to the power of 10, right? 7 plus 3 is 10. Okay.
Yeah.
And the third law is a to the power of m whole to the power of n is a to the power of m times n. Okay, a to the power of mn. That is, if you, for example, it is 2 to the power of 7 whole to the power of 3 can be written as 2 to the power of 7 times 3, that is 21. Okay. Next one. Next law is a to the power of negative n can be written as 1 by a to the power of n. Now here, I want you to see this. For example, you have 2 to the power of minus 5. You can write it as 1 over 2 to the power of 5. Okay, when it comes to the denominator, the negative exponent becomes positive. But at the same time, when you have 1 over 2 to the power of negative 5, if you take it to the numerator, it becomes 2 to the power of 5. Is this clear?
Yep.
Yeah.
And then one more law, a to the power of 0 is always equal to 1. Okay, anything raised to 0 is always equal to 1. Okay, now using these laws, we'll do these questions. So 2 to the power of 5 times 2 to the power of 6 would be 2 to the power of 11 over 2 square, which is 2 to the power of 9. Right? Am I correct?
Yeah.
Is that correct?
Yep.
Okay. Next, write down the value of 14 times 3. Okay, write down the value of 14 times 3 plus 14 times plus 5, 14 times 5 plus 14 times 7, rise to 0. What is its value? Arya, what is its value, Arya?
It should be 1.
Should be 1. Anything raised to 0 is 1. Okay, you see, we just restrict that. Okay, anything raised to 0 is 1. Okay, write down the value of 15 to the power of minus 2. Gia, can you give me an answer for this? Gia, can you give me an answer for this?
I got 1/225.
1/225. Good. 1/15 square. Wonderful. Which is 1/15 square is 15 times 15, which is 1/225. Excellent. Is she correct?
Shouldn't it be like negative
What is that? What is that?
Shouldn't it be like negative 225 because it's like 15 power to the negative 2 though?
That's what. When you remember, look here. When you have a to the power of 9 minus negative sign, it goes to the denominator and becomes positive. 1/a to the power of n. So she wrote 15 to the power of -2 as 1/15 square. Make sense? Which is 1/225.
Yeah.
Yeah. So.
Yeah. Go ahead. Who is that?
What about in the scenario where it's a raised to the power and then it's like a what do you call it, fraction?
Okay. You mean like this, something like this? 3/4 whole to the power of -2?
No. So, like, let's say 2 to the power of half.
2 to the power of -half.
Yes.
I mean that. So it is 1/2 to the power of half, which can be written as 1/2 to the power of half can be written as 1/square root of 2, right?
Yes.
So I mean, see, you can also, there is also one more law. Nth root a can be written as a to the power of 1/n. Okay. So now let me explain you this law. Basically, if you have 3 root of 4, okay, you can write this as 4 to the power of 1/3. And vice versa, 4 to the power of 1/3 can be written as 3 root 4. And I hope you guys know the difference between 3 root 4 and 3 root 4, right? There is a difference between this, okay? 3 root 4 is 3 times square root of 4, that is 2, which is 6. But 3 root 4 is 4 to the power of 1/3. You see that? Understand the difference?
Yeah.
Okay. So basically, if you have 2 to the power of -1/2, you can write it as 1/2 to the power of 1/2, which is 1/square root of 2. Okay. Let's go to the next question. If you're clear with that, let's go to the next question. Shall we go to the next question, guys?
Yes.
Sir, sorry. Please can you quickly scroll up?
What is that? What is that?
Please can you quickly scroll up for the rules?
Which all the rules? You mean all the rules?
Oh, just the last two that I had to copy down.
Okay. Okay. This one?
Like 5.
Yeah. This one. Okay. You want to copy them? Okay. Go ahead. This is the first rule. The second rule. Third one. Fourth. Fifth, and
Free.
Yeah. Thank you.
And then there is one more, sixth. This is 6 laws of indices. Okay.
Yeah. Thank you.
Wonderful. Good. Let's go to the next question. Expand and simplify. This is very easy. You should be doing it in 30 seconds, guys. Go ahead. Muhammad, nice glasses you have, Muhammad.
So I got the answer of 12x squared
12x
plus 13x plus 3.
13x plus 3.
Okay, good. Let's give time for others, those who are not finished.
That was so much more interesting. Yes.
Yeah, I got
Guys?
the same answer as well.
Guys, by the way, is the class interesting or is it very...
No,
is the class interesting?
It's interesting.
It's good.
Very good.
Interesting.
I got the same answer.
Really extremely good.
Very good.
Easy.
Wonderful. Good. Thank you. Now you need to multiply this. Let's do it for those who don't know. 4x times 3x is 12x squared. And then 4x times 1 is 4x.
That guy is calling you.
3 times 3x is 9x.
Dada बुला रहे हैं.
3 times 1 is 3.
अरे जाओ.
So it is 12x squared plus 13x plus 3. Right?
ना जाओ.
Is it correct? Am I correct, guys?
Yeah.
Yeah.
Yeah, you're right.
I got the same thing.
Yeah.
Yeah.
Wonderful.
Yeah.
Wonderful. Now, guys, I want to give you two formulas here. I mean, which will make these multiplications easier. Look here. One is a plus b whole square is a square plus b square plus 2ab. Okay, this will make your life really easy when you are doing complex equations. And the other one is a minus b whole square is a square plus b square minus 2ab. Okay, these two formulas will really help you. Let me explain you how this will work. Okay, for example, you have 2x plus 3 times 2x plus 3. Okay, now instead of multiplying like this, you can directly write this as 2x plus 3 whole square, right? 2x plus 3 times 2x plus 3 is 2x plus 3 whole square. Now you can directly write this as 4x square, that is a square, plus b square is 9, plus 2ab, 2 times 2, 4 times 3, 12x. So it is 4x square plus 12x plus 9. So these two formulas will really help you. If you want, you can.
Wait, I don't get how it's like a squared plus 2 squared when a minus b. It's like a minus b.
See, in the place of a, if you see here, in the place of a, you have, let me change the color just a minute. In the place of a, you have 2x. Okay, in the place of b, you have 3. Okay, so 2x plus 3 whole square. So a square would be 2x whole square, which is 4x square. B square would be 3 square, 9. And 2 times ab, 2 times 2x times 3, which is 12x. Right?
Okay, got it. Thanks. Sorry.
Yeah, no issues, no worries. Good. Now let me give you one more question from this. Okay, I want you to calculate this: 5x square plus 3x times 5x square plus 3x. Go ahead. Can you multiply that? Jonathan, I want you to give me this answer.
25. Oh.
Jonathan Bartholomew. Jonathan, are you here?
Yeah.
Okay, go ahead. Thank you, Jonathan.
So 5x squared times 5x squared. So 25x cubed.
25x to the power of 4, right?
Oh, yeah.
It's not 25x cubed. It is 25x to the power of 4.
Yeah, and then 3x times
3x is 9x squared, right?
Yeah, and then 3x times 5x squared is 15x cubed.
Times 2.
3x times 5x to the power of 2 is 15x.
You see, you have 2ab, right? The last term would be 2ab. So it is 2 times 5x squared times 3x. So it is 2 times 5x squared is 10x squared times 3x is 30x cubed, right?
Yeah.
Is it correct? Guys, is Jonathan correct?
Yes. Yeah.
Ria, is he correct?
I'm not sure, but yeah.
See, basically, you can do the you can avoid using formula as well. You can directly multiply it. See, you can do this. Okay, 5x squared times 5x squared is 25x to the power of 4, and then 5x squared times 3x is 15x cubed, and 3x times 5x squared is 15x cubed again, and 3x times 3x is 9x squared. Okay. So you have 25x to the power of 4 plus 30x cubed plus 9x squared. You see that?
So according to the formula, how would you know what the 30x, well, how would you know if it's cube or if it's squared or if it's just x?
Let me explain you. See, the question is you have 5x squared plus 3x times 5x squared plus 3x, okay? You have 5x squared times plus 3x times 5x squared plus 3x. Okay. Now, the formula is a plus b whole square. Okay. I'll write the formula down. It is a plus b whole square is equal to a square plus 2ab plus b square. Okay. Now, look here. What is a? Whatever is before plus is a. This whole thing is a. Okay, and this whole thing is b. Okay, am I correct?
Yeah, yeah.
Okay, so now you are doing a square here. You see, you're doing a square. So it is 5x square whole square. This is a square plus 2 times a is 5x square and b is 3x plus b square is 3x whole square. You see that?
Yeah.
So now 5x square whole square is 5 square is 25. X square whole square is 25. You just learned the laws of integers. It is x to the power of 4. Right?
Yeah.
Plus, now you have, see, you look here, 2 times 5 times 3 is 30. 2 times 5 is 10. 10 times 3 is 30. X square times x is x cube, right? X square times x is x cube. And 3x square, 3x whole square is 9x square. Okay, that's your answer.
Okay, thank you.
Makes sense, Diksha. You need to practice this formula. But then if you know these formulas, it will become really easier for you. Okay.
Thank you.
Good. Yeah, wonderful. Let's go to the next question. Here you go. Work out the mixing terms in each sequence. This is very simple.
So can I say?
Yes, go ahead.
Okay, first one is 18, and then after 8, sorry, it goes 3, 3.
Yes,
and
it
then,
is 3. You're adding 3. Okay.
No, but that's so.
Yeah.
Add the one before and get the next one.
But
go ahead, Vizan.
6.
Go ahead, Vizan.
3 plus 6, okay, to get 9. 6 add 9.
So we've got A wrong.
15. 15 add 9 to get 24, and 24 add 15. 30.
To get 37.
So what is your answer here? What is your answer here, by the way? Go ahead.
So 9 to 15 is not plus 3.
Yeah, it's plus 6. They're doing the Fibonacci sequence.
Okay. This is a typo error. It is 12 actually. So 3. Okay. So it is plus 3 plus 3 plus 3. So 12 plus 3 is 15. Sorry. Yeah. It is 15 plus 3 is 18.
Fibonacci sequence? Isn't it the Fibonacci sequence?
Yeah.
Okay.
So, it's not a typo, sir.
So I think it's times 1, times 2, times 3, and etc.
It's the past 2 numbers added, which gives you the next number.
369. Okay. Okay.
Yeah.
Go ahead. Yeah. Okay. Yeah.
So it becomes 24.
9.
Yeah.
Okay. 6 plus 9 is 15. Good. 15
and then
plus
24
15
plus
is
15 gives you 39.
Okay. Good.
Yeah.
Wonderful. What about the next one? Izan, you're saying the next one?
Fibonacci sequence.
Yes. What about the next one, Izan? 17. Good.
Yes, 17.
Wonderful. Now, let me give you a sequence, okay? Let me give you a sequence. For example, you have a sequence like this, minus 3, minus 1, 1, and so on, okay? I want you to find the 75th term in this sequence. Can you do that, all of you? Find the 75th term in that sequence. The sequence is minus 3, minus 1, 1, and then...
145. I've got
145,
the
yeah.
answers now. 145.
Okay, let others do.
So for that one, I got 145.
Wonderful. See, this is an arithmetic sequence. Understand this. Okay, you're adding 2 each time, right? You're adding 2 each time, basically, right? So to find the nth term of the arithmetic sequence, the formula is a plus a1 plus n minus 1 times d. Okay, where a1 is first term, okay, and d is the common difference. Okay. So for those who don't know, you can write this down. If you have in an arithmetic sequence, if you have to find the nth term, okay, for example, here I'm asking you to find 75th term. Like that, if you have to find any term, you'll be using this formula a1 plus n minus 1 times d. Okay, now look here. Let's do this. Okay,
So,
so
what
a1
would
is
the n be then?
n is 75th term, right? You are finding 75th term, so n is 75.
Okay.
Okay.
Shouldn't
so
it be
a1? Go ahead. Go ahead.
Shouldn't it be 3, not -3 for the? Because it goes.
No. -3 plus 2 is -1, right?
Yeah, but if you're doing 1 plus 2, shouldn't it be 3, not -3?
No. I'm starting my sequence from -3.
Ah, that last term.
The last term, the fourth term.
Okay. Yeah, this is 3. Yes. Oh, this is not. Oh, this is not negative. Okay. Sorry. Yeah, it's not negative sign there. It's just 3. Okay. Yeah. So now let's start with. Let's use this formula. A1 is -3 plus 75 minus 1 times d is 2. Okay. The common difference is 2. So you have -3 plus 75 minus 1 is 74 times 2. Okay. So -3 plus 74 times 2 is 2 4 8, 2 7 is 14, 148. So it is 148 minus 3 is 145. Make sense?
Yep.
Yes, sir.
Yes. Now, can you find the nth term for this? I mean, just the nth term for this?
It's
2n minus
2n minus 3 minus 5. Yeah.
2n minus 5.
Yes. Good. Wonderful. So it is a is -3 for the finding nth term. Basically, what you do is you play in the place of n, you just put n. Okay. So it is -3 plus n minus 1 times 2. So it is -3 plus 2n minus 2, which is -3 minus 2 is -5. So it is 2n minus 5. So basically, this is a formula for this sequence. So once you know the nth term, you can find any term of that sequence. Right? Wanika, did you understand?
Yeah.
Wonderful. Good. Let's go to the next question, guys. Here you go. Again, the sequences. Here are the first 6 terms of an arithmetic sequence. Find an expression in terms of n for the nth term of this sequence. We just did. I mean, you, don't give answer. I'll ask specific people. The nth term of different sequence is 4n squared plus 2. Ryan says that the 5th term of this sequence is 100. Is Ryan correct? Show how you get your answer. Go ahead. You have 2 minutes time for both the questions.
Sir.
Good, Rahul. Ravi, are you here, Ravi? Ravi. Jack. Naomi.
Yeah, done.
Good. Naomi, are you here, Naomi?
I'm done.
Wonderful. Hussein. Hussein, are you here, Hussein? I can't hear you, Hussein. Good. Let's do it together. Find an expression in terms of n for the nth term of this sequence. Okay. Let's find the nth term. You know the formula is a1 plus n minus 1 times d. Okay. So a1 is 2 here. You see, a1 is 2, and then the d. You need to find d. 8 minus 2 is 6. 3 it is 6. So let's find 2 plus n minus 1 times 6. So that is 2 plus 6n minus 6. So that is 6n minus 4 is the nth term of the sequence. Am I correct?
Yeah.
Yes, sir.
Yeah.
Good. Thank you. Now, can you find for this expression, can you find the 35th term of the sequence? You know the nth term. Just find the 35th term.
206.
Okay, Adya, correct. Is she correct?
Yeah.
Yeah.
Okay, you'll basically multiply. Which term did I ask you to find? 6 times?
35.
35 is 210 minus 6. What is your answer?
206.
No, 6 times 35.
It's like 220, no? Wait.
210.
6 times 35 is how much, Adya? 210 minus 4 is 206.
Sorry, yeah.
206.
206.
206, right? Yeah. Good. Now, Ryan says the nth term of a different sequence is 4n squared plus 2. Look here. The nth term of a different sequence is 4n squared plus 2. Now, let's write the sequence here. Okay. What is the first term? It is 4 times 1 square is 4 plus 2, 6. Second term would be 2 square is 4. 4 times 4 is 16 plus 2, 18. 3 square is 9, 9 4 is 36 plus 2 is 38 and so on. Okay. That's the sequence. But he's asking you to find fifth term. So 5 square is 25. 25 times 4 is 100. 100 plus 2 is 102. You see? But he says the fifth term of this, Ryan says the fifth term of the sequence is 100. Is Ryan correct or wrong?
Wrong.
He's wrong, right? It is his fifth term is 102, not 100. Okay. So Ryan is wrong. Okay. Good. Excellent. Let's go to the next question. Here you go. Oh, this is the quadratic sequence. You know what is a quadratic sequence, right?
No.
Yeah.
For those who can do, can you try that? Find an expression in terms of n for the nth term of the sequence.
Done.
Good.
Done, sir.
Wonderful. 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 Look here. Now let's find the nth term. Quadratic sequences. What are quadratic sequences is, you see 5, 8, 13, 20, 29 and so on, right? Now, if you find the difference between these two, first difference, 8 minus 5 is 3, 13 minus 8 is how much? 5, 20 minus 13 is 7, 29 minus 20 is 9, okay? So, you see the first difference is not same. So, let's find the second difference. It is 2, 2, and so on, okay? The second difference is same, okay? So the quadratic quadratic sequence is a sequence whose second difference is common, okay? Basically, the second difference is common, not the first difference, but the second difference is common. Does it make sense to everyone? Quadratic sequence?
Yes.
Yeah.
Yes, sir.
Okay. Wonderful. Now, how do you find the nth term? See, the quadratic sequence nth term would be of this form: ax squared plus bx plus c, okay? This would be the form of an nth term. Now, you see you have 2, 2, 2 here, right? So, you divide this 2 by 2, so that is 1. So, the first term, 1 ax square, the coefficient of ax square is 1, okay? So, after you divide, after you get the common number like this, second sequence is common, what you do is you divide by 2. So, 2 by 2 is 1, so that will become the coefficient of x square. So, basically you have 1x square. Now, you need to find bx and c as well, okay? So, for that what you do is, you write the sequence, okay? The sequence is 5, 8, 13, 20, and 29. Okay, the term is here. This is the first term, second term, third term, fourth term, and fifth term. Okay. Now what you do is find 1x square. Okay. So first time 1 square is 1. 1 time 2 square. You see here 2. So 2 square is 4. 1 time 3 square is 9. 1 time 4 square is 16. 1 time 5 square is 25. Now you subtract this sequence minus 1x square. 5 minus 1 is 4. 8 minus 4 is 4. 13 minus 9 is how much?
4.
4.
4.
20 minus 16 is 4. 29 minus 25 is 4. Okay. So therefore, you see, you don't have everything is 4. Okay. So the nth term would be basically 1x squared. What would be the nth term, guys? Now, can you tell me those are finished?
N squared plus 4.
N squared plus 4. You see that? Yes. So that's your answer, n squared. But for example, you get a different numbers here. Okay. You get a different numbers here. Then what you'll do is that will be a linear, arithmetic sequence. You can find arithmetic, nth term of an arithmetic sequence. Does it make sense? Quadratic sequence, nth term.
Yes, sir.
It requires little practice. Understand that the quadratic sequence is a sequence whose second difference is common. Basically, the second difference is common. So you'll find the second difference and then divide that by 2. You'll get here you got 2, and 2 divided by 2 is 1. That will be a coefficient of n square. So you have 1n square, and then you'll find the value of 1n square and subtract it from the sequence. You get a linear arithmetic sequence, and then find the nth term of the arithmetic sequence. Does it make sense? Now we are asked to find the 52nd term in this sequence. Can you do that 50?
The answer is 2708 because you do 52 squared, which is 2704, and then you add on the 4.
Okay, so 2704, add on 4, it is 2708. Good, excellent. So for those who did not understand this quadratic sequence, I suggest you practice this because this is a very important question in sequences. You will also have a geometric sequence. Geometric sequence is a sequence which has a common ratio. Basically, arithmetic sequence, it is common difference. Geometric sequence will be common ratio. So I suggest you practice common ratios as well. Geometric sequence as well. Let's go to the next question. Can you try this? It's very easy. Go ahead. The first one is very, very easy. It is 21yz. Okay, that's the answer for the first one. I want you to do the second one. Expand and simplify x plus 3 times x minus 1 times x minus 6 times x minus 1.
First do this.
I'm done.
Okay, good.
I'm done.
Good. Let's ask others.
Me too.
Sahiba, are you done, Sahiba? Sahiba, Mokshi.
Yeah.
Wonderful. Nathan? Stella? Stella? Are you here, Stella?
Yeah.
Good. Are you following us, Stella?
Yeah, it's fine.
Good. Anjani?
Yeah.
Good. Wonderful. Wonderful. Good. Good, guys. Now, what is your answer to this? See, how I do this is, I have x plus 3 here, and I multiply x minus 6 times x minus 1, which is x squared minus 1x minus 6x plus 6. So you have x plus 3 times x squared minus 7x plus 6. Okay. Now I multiply these two, x times x times x squared is x to the power of x cubed. Next, x times minus 7x is minus 7x squared, and x times 6 is 6x. And then now coming to 3 plus 3 times x squared is 3x squared. 3 times minus 7x is minus 21x. And 3 times plus 6 is plus 18. So you group the like terms, you have x cubed. And minus 7x squared plus 3x squared is minus 4x squared. And 6x minus 21x is minus 15x plus 18. So that's your answer. Am I correct, guys?
Yeah.
Yes,
Daniel,
sir.
am I correct? Daniel, am I correct?
Yes, sir.
Yes,
Okay.
sir. Yeah.
Wonderful. 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 Good. Let's go to the next question. Here you go. 3 brothers, Noah, Leo, Harry, go on a holiday together. Together, they have a total budget of £600 to rent a holiday house. The house normally costs £60 per night, but they can get 30% discount if they book early. Calculate how many extra nights they can stay up at the holiday house if they book early, and how much money would they have remaining. Go ahead.
Extra nights.
£60 per night, right? So with £600, they can stay. How many days can they stay? How many
14.
nights basically? £60 per night. 600 divided by 60 is how much? So it is 10 nights, right? But if they book early, they get a 30% discount.
I've got an answer.
Go ahead. Who's that?
They've got 4 extra nights and they've got £12 left.
Wonderful. They got 4 extra nights and then they have £12 left. Good. Good. See, 600 by 10, 600 by 60 is 10, right? So they can stay 10 nights. But now they get 30% discount if they book early. 30% of 60 is how much? Is 18. So £18 is the discount. So each night it will cost them £42, right? 60 minus 18 is £42. So 600 divided by 42 will give you 14 point something. Okay, so they can stay 14 nights, and 14 point, you get 14.285 and something. Okay, so so it is 14 times 42 is 588. You see, 14 times 42 is 588. So 600 minus 588 is £12. So they are left with 12 pounds. You see that?
Yes, sir.
So they can stay, if you get 30% discount, they can stay extra for 4 days, and they also have £12 left. Those who did not understand, those who did not understand, you see, for £600, each night it costs £60 per night. So 600 by 60 is 10 nights. They can stay for 10 nights. But if they book early, say some 3 months or 2 months early, if they book early, they get 30% discount on each day. So 30% of 60 is 18. So 18 is the discount. So 60 minus 18 gives you £42. So each day will cost them £42. So 600 divided by 42 is 14 nights. They can stay for 14 nights. But 14 times 42 is 588. So 600 minus 588 is £12 left. Hope you guys understand. Did you understand, guys?
Yes, sir.
Yes.
Yeah.
Wonderful.
Yes.
Yes, wonderful. Good. Let's go to the next question. The nth term of a sequence is given by, okay, go ahead, try this. Then this is to do with simultaneous equations. This will sort of revise your simultaneous an square plus bn. The third term of the sequence is 42. The sixth term of the sequence is 138. Find the fifth term of this sequence. Okay, if you see this, the third term of the sequence. So let's plug in 3 in place of n. So you have a times 3 square plus b times 3 is 42. Okay, so that is 9a plus 3b is equal to 42. And then this is one equation. And the other equation is sixth term is 138. A times 6 square plus b times 6 is 138. So you have 36a plus 6b is equal to 138. Now you have two equations, you see. So let's multiply. Now let's name this equation 1 and this equation 2. Okay. So let's multiply equation 1 with. Okay. Let's multiply equation 1 with 4. Okay. So 1 times 4 is.
So is the answer
100.
100?
What is your value of A and B?
My value of A is 3 and my value of B is 5.
Wonderful. Good. So that's 100.
Yeah, it's 100.
Yes, wonderful. For those who did not understand, for those who are not able to do it, it is 36A plus 3 times 4, 12B is equal to 42 times 3 is how much? 42 times 3, 4, 3, you're multiplying with 4, right? 42 times 4, 4, 2, 8, 4, 4, 16, 168. And you have 36A plus 6B is equal to 138. Now you subtract these two equations. You have 36 minus 36 is gone. 12B minus 6B is 6B is 168 minus 138 is 30. So B is equal to 5. You see, B is equal to 5. So take this B and plug it in this equation. So you get A is equal to 3. So you know A and B. So the fifth term would be, you see here, you substitute here, 3 times 5 square plus 5 times 5. So that is 25 times 3, 75 plus 25, which is 100. Right? Make sense, guys?
Yes, sir.
Yes, sir.
Wonderful. What about others? Only 2 of you are answering. What about others? There are about so many people.
Yeah, makes sense.
Makes
Did you understand? Makes sense.
It makes lots of sense.
Yeah.
Good. Excellent. Thank you. Yes. The last question, maybe the last question. Anna eats a chocolate every 25 minutes. Sophia eats a chocolate every 15 minutes. How many times between 7 and 11:30 will Anna and Sophia eat a chocolate together? Go ahead if any of you have it.
I've got three times.
Excellent. Good. What about others?
Done.
What is your answer, Nikhil? Okay, so first let's find the LCM of 25 and 15. It is 75 minutes. Okay, that's the LCM of 25 and 15. Okay, now 7 and 11:30. The difference is 4.4 hours 30 minutes, which is 270 minutes. 275 will give you 3 point something. Okay, so 3.6 or something. So basically, they will eat the chocolate together 3 times. Make sense?
Yes, sir.
Good.
Yes, sir.
Right? Yeah, go ahead. Go ahead, teacher.
If we don't divide 270 by 75, but we go like they ate the chocolate together at 7 o'clock, then 8:15, then 9:30, and 11:15, I got 4. I mean 3.6. I didn't divide 270 by 75. I just counted 75 minutes from 7 o'clock to 11:30. They ate together at 7 o'clock. And 1 hour, 15 minutes after 8:15. And then 9:30. And 10:45.
I mean, it doesn't say that they started at 7 p.m. I mean, it doesn't say that they ate the chocolate at 7 p.m. together. Okay?
All right.
Wonderful. Good guys, we'll stop here for this today. Did you all enjoy today's class? Did you like it?
Yeah, it was fun.
Yeah.
Brilliant.
Yes,
Yeah, I enjoyed it.
It was amazing.
Yeah, it was completely amazing.
It was like
Yeah, it was amazing.
Bye.
It was exhilarating.
Bye.
Bye. Thank you, sir.
Thanks, sir.
It was really helpful.
It was splendid.
Yeah,
Really fantastic.
Thank you, sir.
Thank you.
Good, wonderful. See you in tomorrow's
you.
class. God bless you all. See you tomorrow.
Thank you, sir. You too.
Bye.
You too.
Bye, sir.
Bye.